Okay, we're going to take some notes on different function families. So all of these things we're going to talk about are functions, meaning they pass the vertical line test and they have that one-to-one relationship. Every input has only one output. So the first one we've been dealing with all year, a linear function. The most basic form of a linear function is y equals x. And just to review, I'm going to make this a little trickier because we still have some people that are struggling with slope-intercept form. I'm going to give you another form of a linear equation, y equals 2x minus 3, and we're going to graph that. So if you look at this equation, the y-intercept is this constant, this plain old number here, so negative 3. So we go on the y-axis to negative 3, and we have a slope of 2. So from that point, we rise to run 1. And then when we connect these, we see exactly what we've been seeing all year, a line that's continuing in both directions. Okay, so this is what all linear functions look like. But now we want to talk in general. What is the domain of linear functions? And remember, the domain are the x values. So to look at that, you imagine moving across the x-axis. And when we move across this x-axis, do you agree that this line is forever going to spread to the right and forever spread to the left? So our domain is all real numbers. Our range, our y values, if we move a pencil horizontally up and down, this graph is forever going to go up to positive infinity, forever down to negative infinity. So our range is all real numbers. A linear function is either always going to be increasing or always decreasing. Okay? It's never going to be both. So in this scenario is increasing, but we have certainly seen lots of lines that look like this. And in that case, as you move left to right, this line's going downhill, so that would be decreasing. But a line is always going to be doing one or the other. Okay, a quadratic function is the form of y equals x squared. And what that looks like is it hits at the origin. It hits at 1, 1, at 2, 4, because when x is 2, 2 squared is 4. And when x is 3, it's going to be up here at 9. And then we're going to reflect all these points across the y-axis and put their mirror image over here. And you're going to see that you get what's considered a U shape or a parabola. Okay. In this case, the domain, this graph is going to continue to spread out forever in both directions, left or right. So the domain of a quadratic is all reals. But in this case, the range, the y values only start being defined when we get up here to positive y values. Down here, when y is negative, notice that the graph is never going to touch that. So we're going to say our range is all real numbers such that, and we put a colon, meaning such that, y has to be greater than or equal to 0. Quadratic functions do a combination. They increase and decrease, or they decrease and increase. But there's both of those things going on at the same time. So in this scenario, you always start on the left. Notice that this graph is decreasing first and then increasing. Okay, the next function family is absolute value function. And this is again going to hit at 0, 0. Then just going up 1, 1, 2, 2, 3, 3, like this. And it's also going to reflect over the y-axis. So it's going to be negative 1, 1, negative 2, 2, negative 3, 3. And we get what's considered a V-shaped graph. Just like quadratic, the domain, it's going to continue to spread in both directions, is all real numbers. And in this scenario, the range is going to be all real numbers such that y is greater than or equal to 0, because this graph is never going to go down here. Notice that absolute value function is just like quadratics. It either increases and decreases or decreases and increases. The last one is a cubic function, and a cubic function is going to look like this S curve. So we have the point 0, 0, 1, 1, and 2, 8. Because when x is 2, 2 to the third power means 2 times 2 times 2, which is 8. Then we have -1, -1, and -2, -8. So you can see when you connect these, that these are not linear. It makes kind of like this little jog. That's what all cubic functions will look like. This graph is going to continue to spread out all the way to the right and left in the x direction. So our domain is all reals. And it's going to continue in both directions in the y as well. So the range is all reals. And notice that a cubic function doesn't have this turning behavior like up here, where it goes down and then goes up. A cubic function, as you start on the left, this is always going to be increasing the entire time. It's also possible for it to go like this. And in this case, it would continually be decreasing, but it's not going to do both. It's either increasing or it's decreasing. Okay, it's very important that you put this into your notebook. You will be able to use this on your test because all of these function families you are going to have to identify. So if you see something that looks like this U shape, it is called a quadratic function. If you see something that looks V shape, absolute value.